Hello again, welcome back to AU-264, the lecture. Right now, as I'm recording this, it's only Thursday, Friday the 13th. And, by the time this is posted, it will be Monday. And so you probably will know, but I just found out this morning, got an email from the department chair and from the college that we're shut down now completely for, till November 30th. Honestly, a lot of us feel that maybe that shutdown will not end, and we'll just finish out the semester locked out of the training center. So hopefully, I know none of you have projects, at least in my class, that are half done, but we do have, we have one vehicle with an engine apart. I don't know if we'll get a chance to put that back together and ever hear it run or not. But the big thing here, the big thing for us and for this lecture is now labs are going to be online also. So not just the lectures, but also the labs. And so things that I would, maybe talk about in lecture, but then actually do in the lab, everything's going to be on video, at least for a while. So it probably changes a little bit of, just how I'm going to present this stuff. So we're kind of in uncharted territory. I can't honestly say exactly how it's going to go. We'll just do our best to get through this, So let me show you what we're working on now. By now, you've either taken the test or decided not to, and if you've decided not to, then let me turn off my video. If you decided not to, then you pretty much are done anyhow. So those of you that are still left with me, here's, we have talked about mechanical things with the engine. We've talked about physics, things like atmospheric pressure and things like that, vacuum pressure. We've talked about air-fuel ratios a little bit, and we've talked about ignition systems. One thing I want to make sure we get through is diagnosis. So in here, under lessons, I have Module 3 down at the bottom here, right? So we've been through everything in Module 1, right? We did all of the slides. We watched videos on, injection. Well, I don't know if we watched the direct injection one, or gas versus diesel. But these things have been available to you for the entire semester, right? And then Module 2, we looked at, there were several sets of slides. We looked at how transformers work, ignition system operation, what a Hall effect is, how it works. And now, we're going to move on to Module 3. So Module 3, the only thing in here right at the moment are the slides. So if you look, give it a minute here. It's one thing to be able to fix a car, to be able to bolt on new parts or whatever, but what really makes you valuable as a tech is your ability to do diagnosis, decide what is it that we need to fix. And even though there's all kinds of onboard diagnosis now, that doesn't mean the cars just tell you what parts are needed, right? They kind of point you in a direction, and then you've got to finish the job yourself after you get a code. So diagnosis is, half art, half skill. What you're trying to do in as few steps possible is take some sort of perceived concern that the vehicle owner or the driver has, understand what the concern is, and then figure out what's causing it and what the correct, corrective action is. So if we go through here, right? So this presentation is entitled Drivability Diagnosis. So I guess we want to talk about what is drivability. I see I have it spelled incorrectly. Sorry about that. So what is drivability? It refers to the smooth running of the engine. If the engine does not run correctly during all phases of operation, it's said to have a drivability problem. So obviously, if you have flat tires or things like that, it does affect the way the vehicle drives, but we don't call those drivability problems. We would call those, suspension problems, steering problems, brake problems. Drivability is really about how the engine runs. And so there's a set list of symptoms that we call drivability symptoms, and I'll list those in a bit. Should be noted here that some symptoms can also be caused by problems with the transmission. I'll give you a little story. Back in the the early 80s, I guess, I worked at a dealer where we sold the Renault Alliance. That was a 1984 Motor Trend Car of the Year. Kind of calls into question how they determine Car of the Year, but anyhow, it had a unique, for that year, for 1984, electronically shifted transmission. That was very uncommon in 1984. And this electronically shifted transmission had a problem where it had a fuse that supplied the transmission computer. And if that fuse, for whatever reason, popped, the transmission would default to high gear. Now imagine a 1.6 liter engine trying to start a vehicle out in high gear. If you've ever been on a bicycle and forgot to downshift before you stop, and you try to get going again, very, very difficult. So these Renault Alliances, if they try to start out in high gear with a little 1.6 liter engine, very, very, very sluggish, very hard to get the car moving, right? So the symptom, right, that the customer is going to complain of is a lack of power. The vehicle just won't accelerate. So it is a drivability symptom. Lack of power is definitely a drivability symptom, but the cause is it's not an engine performance problem, right? It's a drivability symptom, but it's not an engine performance problem. It's a transmission problem. So we see things like this sometimes. You could actually get a drivability symptom like lack of power. Think about it this way: if you've got a dragging brake, so a caliper is seized, that might give you a lack of power concern from the. You got to keep in mind a customer doesn't know what's causing the problem; they just know what it feels like to them. So if the vehicle won't accelerate or it has trouble getting going or keeping going, they're going to call that a lack of power problem, and it may be caused by something other than an actual lack of power. So I just wanted to point that out before we moved on. So here are a bunch of drivability symptoms. So no start. A no start comes in two flavors, two varieties. So I want to make sure we identify one is really an electrical problem and the other is a drivability problem. So if the starter cranks the engine, we call that crank, excuse me, crank but no start. If it's a no crank situation where the starter's not functioning, the starter motor's not functioning, that's not really a drivability symptom. So that's an electrical problem. So when you see no start listed here, we're talking about starter cranks the engine over, but it doesn't begin to run. Hard to start. So usually that's extended crank time. It doesn't want to start, but eventually it does. Stalling. Typically we think of stalling as an idle problem. You come to a stop sign, you come to a red light, puts off the gas, engine quits running. frequently it's accompanied by the next symptom, rough idle. So if it's idling poorly, it's more likely to stall. I have seen engines, though, that just stop running driving down the road, so maybe it's running at 2,000 RPM and all of a sudden it loses, ignition for some reason, or it loses fuel. Maybe the fuel pump dies, right? So I don't really call that stalling. That just quits running, right? Stalling, we're really thinking more when you come to a stop, you're at idle, it idles poorly and then quits running, right? Hesitation on acceleration. You step on the accelerator, you don't have an instant application of power. There's some sort of a delay. Misfire can typically be felt as roughness in the engine. It can be worse on acceleration. You may not even feel that misfire when the engine is idling in park or neutral. If it's mild, if it's severe, you will. So misfire, what it means is that one or more cylinders are either not firing at all, we call that a dead misfire, or they're not firing well, so the air-fuel mixture is not lighting completely. Lack of power, I already talked about that a bit, right? It's just the engine does not accelerate, the vehicle doesn't accelerate at the rate you would expect it to accelerate at. Surge is kind of a weird one to describe if you've never felt it, but this is a situation where the power from the engine is inconsistent. So it begins to accelerate, and then the power falls off, and then it picks back up again, it falls off. So you have this feeling that, it's almost kind of push-pull feeling in the driver's seat. Idle speed problems, obviously, idle speed could be too low, could be too high. If it's too low, you're probably going to have rough idle and stalling. If it's too high, you may have harsh engagement when it's taken out of park and put into gear. Warning indicators like the malfunction indicator light, that's a drivability symptom. Fuel economy concerns, very, very difficult to verify that. People may have unrealistic expectations, or another problem with fuel economy concerns is fuel economy numbers that are given by the EPA don't necessarily reflect real world driving, the way normal people actually drive their vehicles. So if you have somebody that's a lead foot, they're not going to get the kind of fuel economy that's listed on the EPA's website. And that's interesting. I don't know if you've ever gone to the EPA's website, but fueleconomy.gov, maybe I'll go there in a bit. And then spark knock, we talked about when we talked about compression and when we talked about ignition timing. And we know this is kind of another term for detonation. And we saw the video on detonation and what that kind of looks like and sounds like. So let me say this really, really clearly. We went over the four-stroke cycle. What is an engine doing when it's running? And what is it doing well when it's running well, right? Four-stroke cycle. Just think of this. If the engine's not running or not running well, it's not doing one of those four things well. Either it's failing to take in a good mixture of air and fuel in the correct amounts, or it's not compressing it properly, or problem with the power stroke, but typically you would think ignition, right? Not lighting it correctly, or a problem with the exhaust stroke. Plugged exhaust. In the lab, you didn't all get to see it, but some of you, we did the exhaust back pressure test on a Ford Escape. We pulled the oxygen sensor out, put a back pressure gauge in its place, ran the engine at idle, ran it at 2,500 RPM, and then using rags stuffed into the tailpipes, tried to increase the exhaust back pressure and see what it does on the gauge. So if the engine can't get rid of its exhaust, it can't take in more air. So that's going to definitely limit how fast the engine can run. So what can go wrong on the intake stroke? Well, if the engine is not getting the correct amount of fuel and air, right, we have throttle valve dirty or stuck. What kind of drivability symptoms could that give you? Rough idle that's too high, right? A throttle actuator malfunction, possibly, you could have. What else happens on the intake stroke that can go wrong? Intake valve's not opening properly. What kind of things could cause that to happen, right? Maybe we have a worn cam lobe. Maybe we have a collapsed lifter. Maybe we have rocker arms on vehicles that use them that are bent, push rods that are bent. Maybe the valve timing is off, right? That's going to affect possibly only an intake cam, right? If we have dual overhead cams. So a lot of different reasons why the intake valves might not be working right. Mass airflow sensor not reading correctly. That's an intake stroke problem. That's really going to screw up the computer's calculations on fuel delivery. What can go wrong with a mass airflow sensor? Well, the sensor itself can go bad, obviously. Sensor can be unplugged, wiring problems to it. Another thing that can happen is what we call unmetered air, or other people have called false air, right? Which is air that's entering the engine, but the computer doesn't know about it. And this can happen if the plumbing between the mass airflow sensor and the engine has leaks in it, right? So air gets in through those leaks without going through the mass airflow sensor. The computer is not going to know about that air, so it's not going to add enough fuel. So there you go, plumbing problems, right? We could have intake manifold leakage. We could have, on more complicated, we have variable intake runners. Maybe they're not switching correctly. Holes in things, a lot of different possibilities, right? Vacuum leaks. We could also, part of the intake stroke on most engines is also fuel delivery into the cylinder, right? It is sprayed into the intake airstream, highly atomized. The time that this is different is if it's direct injected. If we move on to the compression stroke, what can go wrong on the compression stroke? Well, air-fuel mixture not being properly compressed, right? So maybe the valves aren't sealing. I think you all saw what happened on that Subaru motor, interference engine, when the timing belt snapped, right? All the exhaust valves are bent, so they don't close. So when the pistons come up on the compression stroke, it just pushes all the air right out the exhaust. So building up no pressure at all. If that timing belt had not snapped, if it had just jumped, or timing chains sometimes jump when they stretch, you could have improper valve timing. That can cause compression pressures to be really low. In the case of that Subaru, right, really low means we had zero. We had wide open valves on the compression stroke. If we have worn cam lobes, let's say we have a worn intake cam lobe, and we don't take in enough air, that can cause our compression pressures to be low. How about worn rings, bad head gasket? And I've seen worse. We talked about pre-ignition earlier on, and in the one slide, you could see that if the pre-ignition went on long enough, it actually could burn a hole right through the top of the piston. And I've seen engines like that. I've seen pistons with holes right in the middle. And guess what you get for compression? Absolutely zero. So, on the power stroke, right? What can go wrong on the power stroke? So our cylinder is full of a properly compressed air and fuel mixture. We have the right amount of air, the right amount of fuel. It's compressed to the correct pressure, but it doesn't ignite or partially ignites. Why? Maybe we got a bad coil, bad spark plugs, bad wires. Maybe the ignition happens at the wrong time. Maybe it happens late, maybe it happens early, right? So think about why the ignition could happen late. On older vehicles, it could be actually adjusted wrong. On a newer vehicle, something wrong with the spark advance system. Maybe the NOx sensor is giving some sort of false indication, right? Or there's a NOx sensor code, so the ignition system won't advance the timing as much as it normally would, right? We could have the wrong fuel octane rating, right? So maybe we actually are knocking, and because of that, that's a bad problem on the power stroke. What else could go wrong? Think about it. And then lastly, and this stroke gets kind of, ignored a little bit, but the exhaust stroke, right? So after the air-fuel mixture is burned, if it's not effectively cleared from the cylinder to make room for the next air charge, we're not going to completely fill the cylinder, and we're not going to have a good combustion event in that cylinder. So what could cause the exhaust stroke? What could go wrong with it? Exhaust valve doesn't open or doesn't open fully. Maybe we have problems with the exhaust cam lobe. Maybe we have push rods or rocker arms that are bent. Maybe the exhaust system is restricted. What could restrict the exhaust system? I talked about this in lab when we did the back pressure test, for those of you that did it. We need to talk about the way a catalytic converter works. So, how does a catalytic converter work? Pretty well, right? But catalyst is something that causes a chemical reaction between two other chemicals, but doesn't actually get involved in the reaction. So in the case of a catalytic converter, when unburned fuel coming out of the cylinder, right, there's always a little bit of unburned fuel. We call it unburned hydrocarbons. Because combustion is not 100% efficient inside the cylinder. So a little bit of fuel makes it into the exhaust. The catalytic converter's job is to take that unburned fuel and combine it with oxygen. And that oxidation process is caused by the catalyst, but the catalyst isn't part of it, right? Just in the presence of those materials, that platinum, palladium, oxygen, and hydrocarbons combine with each other. Completes the combustion, basically. A byproduct of that, of course, is heat. So a catalytic converter in normal operation gets extremely hot. When, for some reason, there's an excess of unburned fuel in the exhaust and in the catalytic converter, the temperature of the catalytic converter can become excessive. So what could cause an excess of hydrocarbons in the exhaust? Typically something like an ignition misfire. So that the air and fuel is not combining in the cylinder. It comes out of the cylinder during the exhaust stroke, hits the catalytic converter, and the catalytic converter, in attempting to make these two things combine, and that byproduct is heat, but it becomes excessive. It becomes really excessive. I've seen catalytic converters glowing red hot under the car. So inside, if you've looked inside a catalytic converter, the substrate is kind of a honeycomb design, and when it overheats, it can actually melt and become blocked. So instead of the fine little passages through it, they seal up from melted material, and now the catalytic converter doesn't let exhaust pass through it. Another thing that can happen, the catalyst can break up inside, and those chunks land in the muffler and block up the muffler. So restricted exhaust, probably the most common cause would be, a meltdown of the catalytic converter. There are other things. The muffler itself can rust out, and a baffle in the muffler could wind up blocking the outlet or something. Anything's possible, I suppose. Somebody could, run over a curb and bend their exhaust, squeeze the pipe flat. I've seen things like that. Back into a snowbank, bend the tailpipe over, back into a fence or a snowbank or a pole or something like that. So anyhow, if the exhaust becomes plugged, the biggest symptom will be lack of power. So let me go back to the slides here a minute. And I gotta share that. Turn me off. Okay, so the question was, exhaust system is restricted by what? Well, the answer to that question is, of course, probably the catalyst. But it could be some sort of physical damage to the exhaust. So if we're going to figure out which, right, we've got all these possible problems, right? Problems on the intake stroke, the compression stroke, the power stroke, the exhaust stroke. Now it's up to us. We have a drivability symptom, right? There was this whole list of symptoms here. Customer comes in and presents us with one of these symptoms. And believe me, they're not necessarily going to use the correct terminology. They just might come in and say it runs bad, right? So it becomes your problem then to convert what they're saying to fit one of these actual symptoms, right? So they might say it runs bad. Well, you might find out that that's misfire, or you might find out that it's a rough idle. So what do we have to do? Well, first thing, verify the condition. How is this done? A lot of times, if you're working in a dealership or you're working in a larger shop, you may not have any direct contact with the customer. So you get a repair order, and the repair order says, car runs rough. And that's it. And a lot of this depends on how good your service writer is, right? So whoever wrote that repair order, if they're experienced, if they're good, they're going to ask questions. So the repair order is going to say, rough idle when it's cold, right? It's going to identify the conditions that it happens under. Maybe it only happens when it's cold. What do we mean it runs bad? Well, it's a rough idle. So they may give you better information, but a lot of times you just get something very, very basic. And so depending on the work environment you're in, maybe you can speak directly to the customer, try to clarify, when does it happen? What exactly are you talking about? I have in the past gone on road tests with customers so that they can kind of point something out. I'm going to suggest if you do that, you do the driving, because I was a victim of a irate customer who launched us off the ground one time. I won't go into details about that, but I decided anytime I went on a road test with a customer, I would do the driving from then on. So how else can we verify the condition, right? Well, we can drive it ourselves. We can ask questions of the customer. We're trying to identify exactly what the customer's concern is. Now, this is not a drivability thing, but sometimes the customers, we don't really know a lot about cars. So let me give you an example. I clearly remember having a vehicle a customer bring in a brand new Lincoln Town Car, complaining about a rattle. And I drove the vehicle, and in the trunk, I could hear the jack and spare tire just bouncing around back there. And I thought, oh, okay, this is an easy one, So I brought it back. I, opened the trunk. I went in there. I stowed the spare tire and hooked it down the way it's supposed to be with the jack, so it wasn't moving around or anything like that. returned the repair order and keys back to the service writer, wrote down what I did, thought that was great. Customer took the car and was back shortly after saying that I hadn't done anything to fix his rattle. And, he wasn't even paying attention to that stuff bouncing around in the truck, which was very, very loud, very loud. Instead, he was complaining about this tiny little sound coming from under the dash. So it's really important that before you try to fix a car, you understand what it is you're trying to fix. I worked at a Lincoln Mercury dealer, and so, we had everything from, town cars, big cruiser, down to the Mercury Lynx, which was the Mercury version of the Ford Escort. And safe to say that if you've been driving a town car for years and you trade that in and buy a Mercury Lynx, the smoothness, performance, and everything else of your new car is probably not going to meet your standards. And so, I had this happen where customers thought that their new car had a rough idle problem, and really it's just a difference between a nice big smooth V8 and a little four-banger. There was nothing wrong with the car. So you could spend days trying to fix a problem that just really doesn't exist. So here's what we were told, and you should. Let me actually get my face back on here a minute. So if you're working somewhere, you need to find out what your shop's policy is on this. We were told in no uncertain terms that if we couldn't verify a concern, right, if a customer said that the car ran rough and we drove it and it didn't run rough, we were absolutely not to try to fix the car. If it ain't broke, don't fix it sort of thing. So we were instructed to write on the repair order, no problem found, and return the vehicle to the customer. And the reasoning behind that is once you make an attempt to repair something, then you're kind of admitting that you agree with the driver that there's something wrong. And if there's not actually something wrong, there is no way you're going to be able to fix it, right? So you're putting yourself in this no-win situation. You might think, well, I didn't feel it misfiring, but let's throw a set of spark plugs in it. Or throw a set of wires on it, or replace the coils. It's warranty, what the heck, right? Well, once you do that, now you kind of own that problem. When the customer says, no, it still runs badly, and you can't now say, well, I didn't notice any problem with it. It's like, well, then why did you try to fix it? Why'd you replace the coils? Why'd you replace the, whatever it is you did? So this goes right back to that statement, verify the concern or verify the symptom, right? So you have to know what it is you're trying to fix. If you don't know what you're trying to fix, how will you know when it's fixed, right? If you've made no change, you won't know when it's fixed. So verify the condition we just finished talking about. Attempt to operate or attempt to operate the vehicle in the same conditions the customer experiences the problem. Does the concern only happen on a cold engine, only under load, etc.? If you cannot duplicate the concern, you may ask the customer for more information or have your service writer do that. So next, and this has changed over the years. When I was working in the dealership, and that was a long time ago, diagnostic trouble codes were the very last thing that we ever looked at because the onboard diagnostics were bad. They were kind of primitive. So they could be fooled very easily by mechanical problems. Still run into this occasionally, on more modern cars. I'll give you an example. My daughter had a Jetta, and that Jetta, shortly after she bought it, used, but it had it had a warranty on it. So it popped up a check engine light, and it was still under warranty, So I could have just taken it to the dealer, but I wanted to see what the code was for. So I just put a scan tool on it and looked. And the code was for coolant temperature sensor. So obviously I didn't fix it, since it was under warranty, but I knew what they were going to find when they plugged it in at the dealership. And so it went to the dealership. They obviously found the coolant temperature sensor code and they replaced the coolant temperature sensor. I might as well turn this back on. As long as I'm just talking to you, right? So they replaced the coolant temperature sensor under warranty, cleared the code, gave the car back. Everything seemed fine for a couple of weeks. I don't remember the exact time frame. This is 10 years ago, 15 years ago. So they cleared it. She drove the car for a while and the light popped back on. Sure enough, another code for coolant temperature sensor. So went into the dealership under warranty. They replaced the coolant temperature sensor. Is that crazy? Is that ridiculous? No, it's not, because new parts have been bad. It happens. But anytime something like that happens, you should be kind of suspicious of it, right? That's not super common, especially with all the quality control they have in place nowadays. So car comes back another few days, weeks, don't remember exactly. The light comes back on. Sure enough, it's a coolant temperature sensor code. So they this time they decided they would put a new connector on the coolant temperature sensor. So the thinking, the logic, I guess, was it must be intermittent, right? It's not the sensor. It must be a problem with the wiring connector. So they put a new connector on it, cleared the code, gave it back. And then over a period of time, the light came back on. And that was when I decided, all right, I need to look at this. So put a scan tool on it and ran the engine. And I watched the coolant temperature sensor reading. And what I found out is it never, ever hit operating temperature. So the real problem with the vehicle was the thermostat was stuck open a little bit. And so that the engine wasn't reaching its normal temperature, and the computer was flagging that as a sensor. Well, the code indicated that it was probably a sensor, but it really was never the sensor. The sensor was correct. What was wrong was the actual coolant temperature was wrong, right? So put a thermostat in the car, and that code never ever came back. Contrast that. So that was a 2003 Volkswagen. I've seen 2015, 2014, 2015 General Motors. So we've gone another dozen years improving on onboard diagnostics at that point. And same problem, bad thermostat, but it didn't give a coolant temperature sensor code. The code it gave was engines not reaching operating temperature. And so that kind of points you more towards the thermostat, right? So the point I'm trying to get across is onboard diagnostics back in the early 80s were horrific. Not horrific. They weren't very sophisticated. Onboard diagnostics now are much, much more sophisticated and much more likely to point you closer into the actual cause of the problem. So when I was being trained, when onboard diagnostics was new, we were told checking for codes was like the last thing you do. And I think that story I told you about the Jetta, the Volkswagen, that kind of explains why. Had we just made sure that the vehicle was actually getting hot, just your basic cooling system problem. That's same system that's been around since way before computers. We would have known that the computer or the computer system or the sensors was not the problem. So that's how I was taught. And then over the years now, I have become a believer that onboard diagnostics are a lot better. And so I do agree. So let me go back to the slide, right? Give it a minute here. I agree that retrieving diagnostic trouble codes after you first verify a symptom is now a valid order of doing things. Do this early. Because onboard diagnostics are so much better now, this is really, really likely to point you in the general direction of a problem. Or you're going to find there is no code whatsoever. And it's absolutely possible you have a drivability symptom without any kind of a code. So no code diagnosis is something you have to be able to do too. So what do? We use a scan tool, retrieve and record all diagnostic trouble codes. I haven't really told you what a hard fault and a soft fault is. I spend more time on this in the spring semester, but just quick and dirty explanation. A hard fault, the problem exists right now. And a soft fault, the problem may be intermittent. So it set a code, but as you check the vehicle out, you may not find the problem to exist. So think of a loose wiring connection. You hit a bump, it flags a code, or it heats up and separates, and it gives a bad reading, flags a code. But when it's sitting in your shop and it's cool, the problem doesn't exist. Or here's a really common one, soft fault. Somebody leaves the gas cap loose. It sets a code, evap leak. Then the next time they fuel up, they tighten the gas cap. They bring it into the shop because the light was on. You see the code for the evap leak, you're never going to find it because it doesn't exist right now. That's a soft fault. On the other hand, a hard fault is, let's say that the filler neck is rotted out. You're going to find that. The problem's going to exist when it's sitting in your service bay. So one of the ways, there's, the different car manufacturers have different ways of separating hard fault from soft fault. Older Chrysler had something called a good trip counter. And if it showed 0 good trips, that means it fails every time it runs. So that's a hard fault. Now they call hard faults active and they call soft faults stored. General Motors uses the current for a code that is, a problem that's happening like on this particular trip or drive cycle. Call it current as opposed to history, which is something that happened in the past. Ford always had what they called on-demand codes, codes that you could force a self-test, the computer to run through its diagnostics, and if it come up with a code right then, that means the problem exists right then. Or it would give you continuous codes, which means part of the continuous self-test that happens while the car is being driven snagged this problem. Doesn't necessarily exist right there in your service bay. So if you have a hard fault, if you erase the codes and it comes right back, it's definitely a hard fault, right? So since you may be erasing codes as part of your diagnostics, it's a good idea to make sure you record all of them, write them down, or take screenshots or something. Get out your phone, take a shot of the scan tool screen so that you don't lose any information. You may want to refer back to that. If a lot of times one problem can create multiple codes. So another thing, before you do any kind of erasing, you might want to look at freeze frame data. That's something we'll get into in more detail. But when you erase the code, you're going to erase that freeze frame data too. So be careful about that. Don't get rid of information you're going to wish you had later. If you have a combination of hard faults and soft faults, obviously start with the hard faults first. Fixing those may take care of everything. And generally speaking, if you have several codes, whichever one comes out first, jump on that one. Now, this semester in the shop, we had a weird, it was a Honda Odyssey van, if I remember right, and one of you owned it. And so I don't remember, but there was a code for the motor mount. This thing has active motor mounts, so the motor mount was bad, and it would not allow you to continue on with the diagnostics for the other code. And I don't remember what the other code was, but you couldn't follow that code chart until you fixed the motor mount and got that problem taken care of. So sometimes you're forced into an order. Okay, so now you've verified the condition, you know the problem you're trying to fix. You know whether it exists right now or whether it happens only sometimes. You know what conditions maybe it happens under. This is where freeze frame can help you too, because freeze frame tells you engine RPM, temperature, engine load, things like that, that the conditions that were occurring when the code was set. So you got your diagnostic trouble codes. They should point you in a general direction for what system we got here, right? You know, if the car's not running right, I said this before, it's not doing one of those things right. You know, it's not taking in an air fuel mixture, or it's not, you know, it's not, hang on one second here. Okay, had just a little interruption there. There was a little noise. So what was I saying? I was saying that one of the systems, something's not happening right. You know, intake's not happening right, compression's not happening right. So what are the problems here, right? If I got a cylinder misfire, you know, what is it? Is it a compression problem? It could be. How can I tell the difference? If it only misfires on acceleration, for example, it's probably not a compression problem. Compression tends to be either good or bad. Doesn't really change with engine operating conditions, right? If a problem only happens cold or only happens hot, probably not something like a bent valve, right? That's going to be pretty consistent all the time. But if it's an ignition misfire, bad coil, weak coil, that might happen under load, right? And not happen at idle, decel, cruise. Fuel problem, you know, what's your concern? If you have a lack of power, maybe your fuel pressure is low. If you have a misfire, maybe you got a bad injector. You know? Air induction, we could have vacuum leaks. We could have, leaks in the air inlet tube between the mass airflow sensor and the throttle body. So these are all the different systems, the different sorts of things that they can cause. EGR, it can cause stalling, things like that. Transmission, I told you about the Renault Alliances, right? They can mimic engine performance problems. You got a bad torque converter, that can be a lack of power concern. If you have an electronically shifted transmission that's not downshifting into first when you come to a stop, or even a manual, old-fashioned transmission, they'd have sticky governors, and sometimes you'd come down to a stop sign and it would downshift into second, but it would never downshift into first. When you want to take off, you're taking off in second gear. So you have this lack of power concern. So you may not be able to actually identify the system by just by the symptom, right? And by the trouble code, but you may. What you're trying to do is you're trying to narrow things down. You're starting with the entire vehicle. Between your, figuring out when the symptom occurs, are there codes, things like that. You're trying to narrow it down. You're trying to eliminate things that wouldn't be the problem, right? Here's one that only takes a minute, but can save you a whole lot of time. Every once in a while, the visual inspection finds the problem instantaneously. So check for loose disconnected wiring connectors. Literally tug on them, make sure they're snapped in place. Loose, disconnected, or cracked vacuum hoses, other physical signs of damage. We're talking a quick check here. We're not saying that you spend a half an hour on this. You're spending, a minute, 2 minutes, and you might save an hour because you see something before any kind of pinpoint testing brings you to that. So it's always worth a quick look. You got an oxygen sensor code, you look and the wires are falling off of it. case closed, right? You don't really need much more diagnosis. Okay, and then diagnostic tests, or another term might be pinpoint tests, right? Sometimes, or I would say usually, the way this goes, right, is you have a customer concern, and maybe you have a check engine light. You check for a code, and that code tells you, right, when you look up that code, there's a diagnostic routine associated with that diagnostic trouble code. So you just follow that like a flow chart, right? So, check this, check that, and it'll just tell you what to do. The real challenge, I guess, is when you don't have a code, what do? What tests are available to you? And so that's what we're going to go through, in next week and things like that. Other tests that are available. We can use a scan tool and do fuel trim, right? So this is using a scan tool, but we're not using the onboard diagnostics of the car. We're using our own observations. The scan tool is just to read data. We can do fuel pressure testing, vacuum test, and some of these things we've demoed or done in the lab, right? Compression test. I know everybody got to do a compression test. Cylinder leakage test. Maybe a timing advance test. I have a little video that I did in the shop on that Subaru engine that's on a stand. I'll stick that in at the appropriate time, where you can see we tested the NOx sensor to make sure the NOx sensor is working. Cylinder balance, that can be done on some cars right in the scan tool. Ford has it built right in. Injector balance, again, some vehicles that's built right into the diagnostic software in the PCM, so you can just access it with a scan tool. Others, you have to do it manually. So we're going to talk about all of these sorts of testing, and unfortunately, with the shop kind of shut down, some of these we may never get to actually demoing. We've done a lot of them. I know we've looked at a lot of them, but some of them we may not. One that's not on here is relative compression. And we'll talk about that, I guess, with the compression test. But it's a very quick way of looking for one bad cylinder. One burnt valve, one cracked piston, or something like that. So hopefully this is giving you sort of an overview. And what we'll spend the next few weeks is just getting into all of these individual tests. Let's see. I gotta shrink my screen here. So hopefully, and I haven't looked yet. Now it's Saturday, so I don't know how many of you maybe didn't do the test, and so you're not even watching this video. But we'll go through each of those different kinds of manual tests that we can do, and then we're going to talk about some other topics like forced induction and stuff like that later on in the semester. So I will not see you in lab, so if you have any questions, I guess email is probably the best way. If you need face-to-face for something, we can do a WebEx too.